We're going to continue our work with function notation in this video by computing what's called the difference quotient of a function. Given a function f, the difference quotient of f is given by this fraction, f of x plus h minus f of x divided by h. This particular concept features very prominently in a calculus class. It's an important quotient for us to be familiar with how to compute. Now, in this particular video, what we're emphasizing is the algebra. So we're just giving you more practice in using function notation by computing the difference quotient. You'll look for other videos in other classes where they will really explain how this quotient is used. The other thing I want to tell you about is that in our MOER learning system, they use a instead of x. So they define the difference quotient as the following. So see how I've replaced the x with the letter a. So that's what I'm going to use in this video when we do the examples. So let's go to the first example. Our function f of x minus 3x plus 5. I hope you're recognizing that as a linear function. So this is a line. You could probably recognize the slope-intercept form of this line, right? And then just a reminder that instead of having the letter y equals mx plus b, right? That's what we're used to seeing. That we're using the f of x, which is replacing y in our function, in our equation. So we want to use this function, this linear function, to compute this difference quotient that we talked about, the f of a plus h minus f of a all over h. So let's take it in pieces. I think if you take it in pieces, it's a little bit easier. So we're going to first compute just f of a plus h. So that little piece first, okay? And now, I know that you know by now that that means that we're going to replace our x in our linear function with the a plus h. So that a plus h is going to replace this x in our function. So I'm going to write negative 3 times, and then where the x is, we put the a plus h, and then just write the plus 5. Okay, and let's go ahead and use distributive property here and just distribute the negative 3. So that we get negative 3a minus 3h plus 5. Okay, so that's our f of a plus h. Okay, so now for the difference quotient, we are going to take f of a plus h, so that's minus 3a minus 3h plus 5. Okay, so that's our f of a plus h right here. And from that, we're going to subtract f of a. So now what's f of a? Well, remember, it's our function where we have replaced the x with the a. So I'm going to write negative 3a plus 5, and then that whole expression is going to be divided by h. So make sure you write that division bar all the way across like that. All right, let's go ahead and distribute here our subtraction symbol here. Let's go ahead and do that next. So I'm rewriting my first few terms. So I got rid of the parentheses, and then here I'm going to write plus 3a minus 5, and again this is all over h. Okay, and then as I combine my like terms, you may have noticed some nice things. For example, this negative 3a and that positive 3a, that gives us 0. And this 5 and that negative 5, that gives us 0. So now we have negative 3h divided by h. And you may have noticed that those h's also reduce. And so our difference quotient just gives us the answer of negative 3. You see how we did that? So again, we replaced x with a plus h first, and then did some algebra work, and from that we subtracted f of a, and then did some distributive work, and we combined like terms and divided by h and got our final result. Let's go now to the quadratic. So number 2, we have a quadratic, so I may have to erase a little bit of this work. Okay, very good. So made some room there, and again we are going to first start with, well, let's do, you know what, let's do f of a. That's easy. Get that out of the way. So f of a is 3a squared minus a. Okay, so we've got that done. Then we're going to do f of a plus h. So again, finding it easier to do this difference quotient just in pieces rather than tackling all at once just kind of keeps it a little bit handy, a little more manageable, I think. And notice how I'm going to put this parentheses here, since I'm replacing the x in the original parabola here with the a plus h, and I have to subtract x, so the parentheses is really important. Okay, so don't miss that. And okay, I have to distribute here. Well, this one gets distributed, this negative, But then here you know that we are going to have to do this squaring part first, right? The a plus h squared, because your exponents have to be done before multiplication, as you know from your order of operations. So I'm going to rewrite the 3, and then this is a plus h times another a plus h, and we're going to do a bit of foiling, aren't we? And then here, just since I'm here, I'm going to go ahead and distribute that negative. Minus a minus h. All right. And then here we're going to foil. We're going to first outer, inside, and last. So I've got my 3, and then I have a squared plus ah plus another ah, ha and ah, which are the same thing, and then plus h squared. And then I'm tagging along the minus a minus h. All right, and now I'm ready to distribute this 3. It's 3, so I have 3a squared plus 3ah plus another 3ah. I'm going to combine those to be 6 in a minute. Plus 3h squared minus a minus h. Getting complicating, isn't it? Okay, so now let's see. Let's combine some like terms here. So what have we got here? These two. We're going to combine those two. Okay, so we have 3a squared plus 6ah plus 3h squared minus a minus h. That's just your f of a plus h. Okay, so so that's a little, you see how it can get unwieldy with all of these terms. You have to be super careful and very detailed with this. Okay, so now let's write the difference quotient. Let's take our two pieces here. Remember, it's f of a plus h minus f of a all over h. So we're going to replace that. So our f of a plus h, we're going to put in the 3a squared plus 6ah plus 3h squared minus a minus h. And then from that, we're going to subtract the f of a. So let's put a parentheses, and we take our 3a squared minus a, right, from our f of a, right? This came from here. Do you remember? Okay. And then we are going to distribute this negative. Oh, and of course, this is all over h. Can't forget that. And so now we get what? So 3a squared plus 6ah plus 3h squared minus a minus h minus 3a squared plus a all over h. I know there's a lot of terms. You just have to be really careful to keep those all together. Okay, so now, but we do have some things that are going to give us 0. So 3a squared and minus 3a squared, that's a 0. And the negative a and the positive a, that's a 0. Okay, nothing else combines. So this is what we have so far. We have a 6ah plus 3h squared minus h all over h. Now, you may have noticed that all of the terms in the numerator have an h in common. Do you see that? That's a GCF. I'm going to actually factor that out. Take that h, factor it out. And so I got 6a plus 3h minus 1, like that. This is kind of cool because now those two h's cancel, right? They reduce. And so our difference quotient, which started out so messy looking, ends up with being 6a plus 3h minus 1. Okay, let's do one more example here. Okay, so here we have f of x equals 7. Do you recognize that function? This is a line, isn't it? And if you recall that f of x is replacing the letter y, we have here y equals 7, and that's our constant function, right? That is our horizontal line. So constant function, horizontal line. So I just want you to keep that in mind. Okay, but process is the same. So now we're going to do f of a. Okay, but you're going to say, but you know, there's no like x for me to put a into. You're right. So f of a is just 7. Okay, and then we're going to do f of a plus h. And you're going to once again tell me, but there's no x for me to substitute a plus h into. You're absolutely right. F of a plus h is 7. That's why it's called the constant function, because no matter what I put in here for my input, my output is going to be 7. Doesn't matter what my input is, my output is 7. So that means that the difference quotient is, and again, right, f of x, a plus h minus f of a all over h. So 7 minus 7 all over h, which is 0, divided by h, which is 0. So this is an interesting difference quotient. When you have a constant function, your difference quotient is 0. So our difference quotient is 0. And what other feature of a horizontal line do you remember is equal to 0? Well, if you set the slope, you're absolutely right. So one of the ideas that I want to leave you with is the idea that our difference quotient is a very fancy way of calculating slope. What's good about it is, and you will see this in your pre-calc and calculus courses, is that we can then calculate slope when we have graphs that are not necessarily straight lines. I hope this helps.